Hey everybody, Dr. A here. In this video, we are going to be exploring another example of systems of equations using the graphical method. So like always, you need to write this stuff down. Watching and just listening is usually not enough, especially if this is new to you. So you want to write this down in a nice, organized fashion. So let's get started. The given information, we are told to use the graphical method to solve the system. Is the system consistent? All right, so our given system is x plus y equals 3, and our second equation is 2x plus 2y equals 6. Now, if you remember, the graphical method for solving equation systems is the most efficient when you have two equations with two variables, and that's what we have here. And what we do is we simply plot the two equations on the same set of xy axes, and we see how these two lines interact with one another. Okay, and then a system is considered consistent if it has at least one solution. All right, so that means it has one solution or it has infinitely many solutions. So let's go ahead and get started. Well, the first thing we can recognize after we write solution is that equation 2 looks a lot like equation 1 times 2. And in fact, that is the case. If you notice, equation 2 here, our second equation, is basically, it comes from if you took equation 1 and multiplied everything by 2. So let's go ahead and rewrite equation 1. We have x plus y equals 3. Now equation 2, I can factor out a 2 from both sides of this equation, and I end up with 2 times the quantity x plus y equals, of course, 2 times 3. And we see that these 2's cancel. So equation 2 becomes x plus y equals 3. All right. So our system is now expressed as x plus y equals 3 and x plus y equals 3. So both of our equations in our system are identical to one another. So you should make a note of that. See what's happening here, okay? Let's keep moving forward, though, with the graphical method and see what comes of this. So if you watched the previous example 1, the most convenient thing to do when you want to graph a linear equation or a system of linear equations, write the equations in slope-intercept form. So we can say in slope-intercept form, we have the following. Our first equation becomes y equals negative x plus 3, and sure enough, our second equation is also negative x plus 3, y equals like negative x plus 3. All right, so let's keep going. I'm going to go ahead and sketch my Cartesian axes. This is my y-axis. This is my x-axis, and I'm going to scale off my values. Okay, we're going to have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Let's label these like good mathematicians that we are. Negative 1, negative 2, negative 3, negative 4, negative 5. 1, 2, 3, 4, 5. Negative 1, negative 2, negative 3, negative 4, negative 5. Okay, on your own paper, write this out a little bit more organized than how I'm doing it. Maybe use a straight edge so you can draw straight lines, and make sure your labels on your axes are evenly spaced. And let's go ahead and plot this. So if you notice, again, we have the same equation twice. We have a positive 3 giving us a y-intercept of 0, 3. And then we have a slope of negative 1. So we have a decreasing linear function. And of course, we can plot this like so. All right. And again, because you have the same equation just appearing 2 times, that means that you essentially have 2 lines lying directly on top of each other, okay? So if you wanted to try to plot the second one, you'll find the second equation, you'll find that it just lies directly on top of the first equation, okay? And so what this tells us is we have infinitely many solutions, okay? So since the equations are the same, we have infinite solutions. So what that means is that every ordered pair, x comma y, that satisfies the first equation also satisfies the second equation. What that means is these equations, they technically intersect at infinite points because they lie on top of each other, all right? So let's write that down. Every ordered pair, let's see if I can spell things correctly. Every ordered pair, x comma y, satisfying the first equation also satisfies the second equation. So it's like these two equations are intersecting at infinite ordered pairs at infinite points. So thus we have infinite solutions, and because we have infinite solutions, the system is consistent. And that concludes this video. If you liked it, hit like and subscribe, and take a look at some other videos on some other topics that you may be interested in or may find helpful. Thanks.